In the previous video, we have seen how to calculate the total electric field at a given point of interest due to the presence of different charges at different locations. Here now also we will solve another problem, an interesting one. See, this is the problem. There are 8 identical charges, point charges, identical charges which are of q coulombs are placed at different corners of a cube of side length A, with one charge at the origin and with the 3 nearest charges are at the respective points. Find an expression for the total force that is acting at point A, A. Sorry for that. The question is, find the expression for the total force field F at the point of interest A, A. Okay, if this is the question, then we need to calculate the force that is acting at this point due to the presence of the charges which are placed at the corners of the cube. And we have been given only 3 points. So it is why I said interesting problem, because we need to calculate the positions of the corners of the cube, knowing the information of these 3 points, and then calculate the overall force that is acting on the given point of interest. So for that we need to draw the coordinate systems and locate the nearest charges and try to find out the positions of other corners of the cube. Let us do that first and then go to the problem solution. Okay, so how to solve such problems? We need to first draw the coordinate system. Okay, the coordinate systems is given by x, y, z like this, and one charge, that means one of the corners of the cube, is placed at origin, right? So origin being one of the corner of the cube, so let me take that as one position of the corners of the cube. Then other 3 nearest points are also given, which is A, 0, 0. That means x is A, y and z are 0. Y, z 0, x is A. Let me take that A. This is A dimension along x. So my point becomes A, 0, 0 here. Then another point is at 0, A, 0. That means on y-axis. Okay, so this is A. So this is 0, A, 0. Then another point is on, let me take this as Z, because this as Z. This is Z and this is Y. Okay, now Z is at Z is A and remaining 2 are zeros, so 0, 0, A, the point on Z axis. So this is A, and this is A. These are the nearest corners of the cube. Now we need to build a cube out of it. So cube can be drawn like this. The other corner can be A dimension apart along x, A dimension along y, this is along x, and A dimension along z, that means the elevation. Okay, and in the same way A dimension, because the dimension of the cube is A. Okay, this is along z again A, this is along y A, and this also is along z A, this is along x, this is also along x, so yes, this is x, this is along z, and this is along x. So I have formed the cube, and now I get to know the positions of other corners of the cube, which is, this is one point, this is one point, this is another corner point, this is another corner point, right? This is one of the corners. Now because I know the dimension of the cube, I have moved that dimension amount along x direction, along y direction, along x direction, and along z direction, and formed the cube. So now my other positions of the cube are, this is positive x, this is also positive y. So this point will be positive x a, positive y a, and this is in the z is equal to 0 plane. And in the same way here, this point is in the z it is a dimension elevated, and along y it is a, and along x, along okay, let me write this point first. This is a comma a comma a, and this is z is a, and this point is varying in z, but it is remaining constant the other two terms. So it is a comma 0. Okay, we are moving z in along z a dimension, so it is already a comma 0 here, so a comma 0 comma a. And in the same way here also a comma 0, I am elevated along z, that's why this point become a comma a. Then I already know this point, so I can write from this point only, 0 comma a, I am moving along y direction a amount, so the point becomes 0 comma a. Okay, we are not moving along x, we are from this point we are moving along y, and hence I can write this point as 0 comma a. Now I have written all the 8 corners of the cube. This is first corner, second corner, third corner, fourth corner, fifth corner, sixth corner, origin being the 7th corner, and this corner is a comma a is 8th corner. So my point of interest is one of the corners of the cube. What is the point of interest? We need to calculate the point total electric field at this a point, which is nothing but one of the corners of the cube. Okay, so and 8 identical charges are placed. How much charge? Q coulombs. So here Q, this is also Q, everywhere Q coulombs is present at all these points. And we need to calculate total, what is the total force that is acting at 8th point. Okay, so for that we need to use the superposition theorem applied Coulomb's law formula, which is F is equal to Q by 4 pi epsilon naught summation k is equal to 1 to, how many charges are there, how many sources are there? If you are excluding the point of interest, there are 7. Okay, because one of the point of interest is one of the corners, so the remaining 7 charges are there on the other corner, remaining corners. So there are 7 point of sources and 1 point of interest. Okay, so I am writing the point of sources 7 as k is equal to 1 to 7 qk by r minus rk magnitude cube into r minus rk vector. Okay, so this is the formula. Now let me expand this. Since all the charges are identical, this q is also common for every point. So I am bringing this q k, which is nothing but q coulombs, outside and writing q square here. Okay, and 4 pi epsilon naught, I already know the value. It is 9 into 10 power 9. Okay, so F is equal to q square by q square into 9 into 10 power 9. Keep it aside and let's find out this entire term. In order to write this expression, we need to know the distance vectors and the magnitude of all these points with respect to the point of interest. Okay, let me write individually all these vectors. I will call the first point, what is my, I have noted down the points, right? So first point is the distance R1 is the distance between the first charge to the point of interest, which is nothing but point of interest minus POS1. Point of interest is a, minus point of source is, my source is at a comma 0 comma 0. Okay, so its vector is 0 a ay. It is a ay and plus a az. Okay, and its magnitude is, the magnitude of R1 is under root of a square plus a square, which is under root 2a. Okay, next, in the same way, what is R2? R2 is POI minus POS2 in the similar way, a comma a comma a. My point, second point is a comma 0. Then I will get the vector as a minus a 0, a minus a 0, a minus 0, a z, and its magnitude R2, which is a. Magnitude of R2 is a. Next, R3 vector, point of interest minus third source. Where is the third source? 0 comma a comma 0. 0 comma a comma 0, which is a minus 0 is ax, a minus a is 0, a minus 0 is a, which is along az. So I can write again its magnitude. This is the vector and this is the magnitude. Magnitude of R3 is under root of a square plus a square, which is under root of 2a. Next, magnitude, fourth position vector, I have to write point of interest minus point of source. What is point of source? Fourth point, 0 comma a comma a. So its vector is ax, then a minus a is 0 and a minus a is again 0. So it is only ax, and magnitude of 4 is a alone. Okay, then fifth vector, okay, is point of interest minus point of source. Fifth point, where is my fifth point? Here, 0 comma 0 comma a, 0 comma 0 comma a, which is a minus 0 is ax, a minus 0 is ay, a minus a is 0, and hence its vector magnitude, its magnitude is under root 2a. Next, sixth vector, minus, where is my source? Sixth source, a comma 0 comma a. A minus a is 0, a minus 0 is ay along y direction, a minus a is again 0. So its magnitude is a alone. Next, seventh vector, a comma a minus, seventh point is, where is the seventh point? Our origin, 0 comma 0 comma 0, which is ax plus ay plus az. Its magnitude of 7 is a square plus under root of a square plus a square plus a square, which is under root of 3a. So by knowing the entire distance vectors and distances calculation, magnitudes of those distances that we have calculated, we need to substitute in the above thing. There must be 7 terms coming here. Okay, and each of the 7 terms has its own R1 vector, R2 vector, R3, so on, R7 vectors with the magnitudes. Let us try to write if it fits this board. R1 vector is, the distance is this, R1 vector being a times of ay plus az divided by its magnitude cube, whole cube, right? So it is root 2 whole cube into a cube. Next, R2 distance, it's just az, and its magnitude is a. Next, R3 is here x and z. So a times of x and z by its magnitude. What is its magnitude? Root 2a. Root 2a whole cube. A cube. Fourth one, which is a again, but along x direction. A ax. Try to simplify a cube kada. So this is a cube, magnitude cube. Then there are 4 vectors I have fitted in. You can solve the rest, okay? You can substitute the rest, which is, it is becoming clumsy, please don't mind. It is a times of x and y divided by under root 2 whole cube a cube. Then 6th vector, it is ay along ay, a by a cube. Next, 7th vector, all the components, a times of ax, ay, az by what is it, root 3a. So root 3 whole cube a cube. So there is a common thing, a in the numerator, a cube in the denominator. We can take, we can cancel a square. You will be getting a square commonly in the denominator and bring that a square outside. And then simplify by substituting root 2 whole cube and root 3 whole cube and just 1, and individually you try to add the like terms, like that means ax components, ay components, az components, and find out the final expression, and then multiply with the quantity that is coming, I mean the whole coefficient. Okay, then you will get certain answer. I will write the answer directly, but you please try to calculate. This is the expression to be evaluated by yourself. Okay, so the finalized expression I am writing here. Total force that is acting on the point of interest a comma a comma a, which is one of the corners of the cube, is F is equal to 17.09 q square by a square into ax cap plus ay cap plus az cap into 10 power 9 into 10 power 9 newtons. This is the final answer. Because q value is not given, a value is not given, you can directly write down the final expression. Okay, this is the final expression. This is how you can solve. This is a very typical model that we have solved. You need to understand what is given in the question, and you need to use the coordinate systems in order to get the extra information which is not there in the question. Okay, so that's how we try to solve different problems that are given. This is one of the model. All the 3 problems we have solved is in rectangular system, but in some cases you will be given the position vectors in terms of other coordinate systems such as cylindrical system as well as spherical system. We need to have that knowledge also. How does the point form looks like in different coordinate systems. We will try to solve other set of problems in upcoming lectures, but for now this is the concepts that we have learned. See you in the next video.